Okay, the area of a trapezium. There are many ways you can do this. You may have seen in lesson that one trapezium, if you turn it upside down, you can turn into two trapeziums, which will make one big parallelogram. So hopefully you can see the parallelogram there. And the good thing about that is the parallelogram, as you saw in a previous video, is easy to calculate by doing the base times the height. Now, when you're calculating the area of the parallelogram, you need to find the other length. So if it was 4 on top, it's now 4 below, and if it was 8 on the bottom, it's now moved to the top. And you could do this using tracing paper. Now if we look at the area now of the parallelogram, like I said, it was base times height, so we need to work out the base of the big parallelogram. You can see you've got a length of 8 and 4, which gives you 12 centimetres. Then if we look at the height, that's taken from the inside, that is still 5 centimetres, that has not changed. So if you want to calculate the area of the parallelogram, we just need to do 12 times 5, and that gives us 60 centimetres squared. Now this is the area of the total parallelogram, which is 2 trapeziums. So if this is 2 trapeziums, we still need to divide that answer by 2 to get us back to the one original trapezium, which is going to give us 30 centimetres squared. Now this is not the only way that you can do the area of a trapezium. There is a formula you can use, and there is different ways you can use it. So you can have a formula which says A plus B, which are 2 parallel sides, times the height, and then half of that. Now that is one way it can be seen, or alternatively the exact same formula is seen like this as well, a half of A plus B times the height. But they're the same thing, so it depends how you wish to use it. Now A and B are the 2 parallel sides. So if we draw the picture again just so you can see it a bit clearer, from the original one we've just done, A and B were the 2 parallel sides, which were 4 and 8. So A and B. So you add the 2 parallel sides together, 4 plus 8, you times it by the height, which in the picture was 5, so keep that in brackets, and then you divide that by 2. If you finish off that calculation, you've got the 4 and the 8 making the 12, you times in that by 5 to get the 60, and then you're halving that 60 to get the 30. It's the same answer, again centimetres squared, and that's just the formula version. Now you can hopefully see why the formula exists, because if you see the 2 trapeziums which make the parallelogram in the first place, if the first one was A and B and you turn the trapezium upside down, you then get the B and A on the other side, and this is all you're getting from the formula. So A and B, when you're adding those together in the formula, A plus B is actually just the base of the parallelogram. You then timesing it by the height, and then you're halving it because it was only one trapezium in the first place.